Hey guys, Mr. B here again, bringing you another awesome math video. This one on solving a system using elimination. So in this video I'm going to do three slightly different examples, and use the method of elimination to solve these linear systems. So if you're looking for a video on substitution, I've already got one of those done, you can check it out, and there's plenty on the internet. So the object of elimination is to eliminate a variable from our system. So the way we do that is we add or subtract the two equations that we have. But in order for a variable to be eliminated, they have to be either equal or opposite. So if you look at my system here, I have 3x plus y is equal to 5 and 9x minus y is equal to 15. So if you look at the y's are opposite. So what I can do to eliminate those variables is I can simply add the two equations together. So I'm just going to rewrite this. So 3x plus y is equal to 5. And I'm going to add to it the second equation. So the reason I'm adding is because what's going to happen is when I add y plus negative y, it's gone away. So these y's are actually going to cancel. So they're gone. And now so I add my x's, so 9 plus 3 is 12x. And 5 plus 15 is 20. So it divides both sides by 12. And x is equal to 5 over 3. So that's my x value. Now in order to get my y value, I have to sub back into one of the equations. So neither one of them right now is solved for y, so it doesn't really matter which one I pick. I'm going to pick the top one. So I have 3 times 5 over 3 plus y is equal to 5. So I multiply this together, so 3 times 5 over 3 is actually just 5, because really the 3's cancel. 5 plus y is equal to 5, or y is equal to 0. So there she is. So my solution, again, solution is a point. Make sure you write it as a point. My solution is 5 over 3, 0. So not the best solution, but it is what it is. You can always plug it back in if you want to check it. So yeah, so hopefully guys that example made sense. So that's not that hard of an example because I didn't really have to manipulate the system at all. I have to multiply by a number. So this example we will have to do that. So if you look at this example, I don't have opposite variables. So the closest thing I have is the y and the 5y. So usually if there's a variable without a number in front of it, that's the variable I'm going to pick to eliminate. So in this case I'm going to eliminate y. I'm going to multiply the top equation by negative 5. And the reason I'm choosing to multiply by negative 5 is because I like to always add my equations. So I'm trying to get opposite values. So if you like to just subtract them, you can multiply by 5 and then subtract the two equations. So my new equation is going to look like negative 10x, so that's 2x times negative 5 is negative 10x, plus 5 times negative y, so that's negative 5y is equal to 25. And then add to that my second equation, which hasn't changed, 3x plus 5y is equal to 3. So you can see again, when I add these together, they'll cancel. So negative 10 plus 3 is negative 7x. And 25 plus 3 is 28. Divide both sides by negative 7. So x is equal to negative 4. So now that I have that done, I'm going to sub it back in to one of the equations. So I'm going to choose the first one because that has y by itself, so that'll be a little bit easier to calculate. So 2 times negative 4 plus y is equal to negative 5. So that's negative 8 plus y is equal to negative 5. So we add 8 to both sides. Probably see what the solution is. Y is equal to 3. So yeah, guys, I hope this is a great example. It's not too bad. It's not too hard. Make sure you write your solution. Negative 4 and 3. All right, let's try one more example. This time we'll have to multiply both equations by a number. So in this example, you can see I don't have anything that's by itself. So there's no just y or just x. I do, however, have a negative and a positive y, so negative 2y and positive 3y. So these, I'm going to choose to eliminate y again. Again, it doesn't matter what one you eliminate. These fluked out that y has been the best one each time, but it doesn't matter. You can do x or y. So in order to get these guys to be opposite, I look at 2 and 3, and I think about the common denominator of 2 and 3 is 6. So really the easiest thing to do, if I multiply negative 2 by 3, so I'm going to multiply the top equation by 3, and then I'll multiply the bottom equation by 2, then this guy will be negative 6 and this guy will be positive 6. So I got 6 times 3, it's 18x, negative 2 times 3, so that's plus 6, sorry, negative 6y. So again, I do plus negative, just makes it easier for me to see. And then 3 times 21, that's 63. I'm going to add to it 8x plus 6y is equal to 2. And then I'll have 18 plus 8, so that gives me 26x. And that these y's cancel, and that's equal to 63 plus 2 is 65. So now I have divide both sides by 26. X is equal to 65 over 26. Not a nice number at all, really, but it works out pretty good. 2.5. Now I need to solve for y, so I'm going to choose the second equation. No reason. Just not many negatives there, so that's kind of why. Sub my x into it. Now I'm going to solve for y. So I have 4 times 2.5 is 10, plus 3y is equal to 1. So I'm going to subtract 10 from both sides. I'm left with 3y is equal to negative 9. Divide both sides by 3. Y is equal to negative 3. And there we go. So our solution is 2.5 and negative 3. So guys, I hope this helps. Short little video on solving systems using elimination. Thank you very much for watching. Please subscribe, and I'll see you guys in class.